All right, guys, this is the review for the retest for composition and inverse functions. We're going to go through it. There are 2 pages to this. Please remember that if you want to take the retest, you need to have printed out this review and completed it, and you must bring your completed review to the retest in order to take the retest. All right, guys, we're looking at questions 1 and 2, where they tell us to find the domain of each function. And so, we ask ourselves the question, does this function have a domain restriction? And if you look at question 1 or equation 1, it is a rational function, and you guys are really good at rational functions because you've been studying them a lot recently, and what you know about them is that they have asymptotes. Those asymptotes happen where the bottom is equal to 0, so where x minus 5 is equal to 0, and that's where x equals 5. And there is an asymptote at x equals 5, and that means that the domain of this function is negative infinity to 5 and 5 to infinity. You could also write that as x cannot equal 5. Ooh, that's not a 5, guys. Goodness, you could write it as x cannot equal 5. I always write it in interval notation, that's just me. All right, guys, but you have to exclude 5 from the domain. That's the important thing, is that we have to exclude 5. We do that here with our parentheses around 5, and we do it here with the not equal sign. All right, guys, looking at question 2, if you look at 3x minus 4, that is a line. So if that's a linear function, we all know what the domain of a linear function is. It is negative infinity to infinity, or all real numbers. So the domain of that function is just all real numbers. All right, guys. The next set of problems deals with combining functions. So we are going to use f of x equals 3x plus 1 and g of x equals x minus 5 for all of these problems. We're just going to combine them in different ways. The first one is addition. And so I'm just gonna combine them now. I'm calling this h of x because that's what it was called. And so this is 3x plus 1 plus x minus 5. So h of x equals, combine like terms, 3x and x, that's 4x. And then I've got the 1 and the negative 5, so it's minus 4. So h of x equals 4x minus 4 in this situation. And because we just added them together. The second operation we're doing with number 4, we are subtracting. And because we are subtracting, we need to be a little more careful. So in this case, h of x, and again, I'm calling it h of x because that's what they called it in the directions. So guys, h of x equals 3x plus 1 minus x minus 5. And what you have to be careful of is that that negative distributes into this parenthesis set. So you really need to make sure you use parentheses with this. So h of x equals 3x plus 1 minus x plus 5. And again, combine like terms, I've got a 3x and a negative x, so that's h of x equals 2x, and then I've got a 1, we'll squiggle that a little more, and a 5, so it's 2x plus 6. And so that's our answer there, h of x equals 2x plus 6. The next one's a little more fun. We are multiplying, and I know that it looks like there are 2 g's right there. That's an eccentricity of this program, I think. It is just f times g. So we're going to multiply them. So h of x, and again, I'm using the 3x plus 1 and the x minus 5, and those are on your paper. You just can't see them right here on mine. But I multiply them. So 3x plus 1 and x minus 5. And you guys know I like to distribute. So here h of x equals 3x times x is 3x squared. 3x times negative 5 is negative 5 x, 1 times x is x, and 1 times -5 is -5. And when we combine like terms, we get h of x equals 3x squared minus 4x minus 5. And that's our answer there. All right, guys, for number 6, it's our last combination problem. We are dividing, and so you just write f over g. So that's 3x plus 1 over x minus 5, and there's not any work to do here, but we do need to remember that that's an x minus 5 in the denominator, which means we need a domain restriction. We need to say, hey, that denominator can't be 0. So we need to say, what can x not be? And the answer is x cannot equal 5. And so we have to say that. All right, guys, 7 through 9 have us doing a composition of functions. So when I'm looking at this, f of x is x plus 2. That is linear. And so we don't need to worry about that function. But g of x is rational. And that function, 1 over x minus 7, that function cannot have an x value of 7. X cannot be 7. And so as we're going through these problems, we need to keep that in mind, is that no matter what, x cannot equal 7. And we have to state that every time. So for the first one, h of x is equal to f of g. So g goes inside f. So here, my outside is f, so it's something plus 2. And my inside, which is the thing that we put into those parentheses, is 1 over x minus 7. That goes in those parentheses there. And so f of g of x is equal to 1 over x minus 7 plus 2. And so that's just 1 over x minus 7 with a plus 2 on the end. Now we need to remind ourselves, and anybody who's watching, us do this problem or looking at our answer later, that x cannot be 7. That's really important. X cannot be 7. And that's because of that restriction right there, but it's also because it's part of this problem here. All right, let's look at g of f of x. So here, our outside is the g function, so that's 1 over something minus 7. And our inside, I'm going to remind myself real quick, is x plus 2. And so that's what goes into those parentheses right there. So h of x equals 1 over x plus 2 minus 7. This is 1 over positive 2, negative 7. That's x minus 5. Now that's our final equation right there. But remember, I told you that every problem we do has to reference that domain restriction. So x cannot be 7, and that comes from that domain restriction from the very beginning, right there. Now, in addition, we have a new equation with a new denominator, right? And so I've got to determine what value x cannot be for that denominator. So what minus 5 is 0, right? X minus 5 is 0, which means x is 5. So if I plugged in 5, I get 0 for the denominator. So I add that to my list of things x cannot be. X cannot be 7 and x cannot be 5. All right, number 9 is super good times. We are going to put the function f into itself. So in this case, our outside is something plus 2, and our inside is also x plus 2. And so we put that into the parentheses. So h of x equals x plus 2 plus 2. So h of x is x plus 4. And because I did not use g at all, I don't need a domain restriction. All right, guys, that is it for the first page. Moving on to page 2 of this review. We are almost there, kids. So, looking at questions 10 and 11, we are asked to determine whether these two functions are inverses of each other. Inverses of each other. And the way we do that in pre-calculus is we ask ourselves, is f of g of x equal to g of f of x, and is that equal to x itself? So what we do is we do one composition. That's what f of g of x and g of f of x are. We do one composition and we see, do we get x? And if the answer is yes, you do the other composition to see if it works out the same way. And if they both come out to simplify down to just x, then you know you have inverse functions. However, if either of them does not simplify to x, you do not have inverses. So we're going to do the first composition first. So f of g of x. And here my outside is f. So that is something squared minus 3. And my inside is plus or minus the square root of x plus 3. That whole thing goes into those parentheses. So h of x equals something squared minus 3. And that something is plus or minus the square root of x plus 3. Now guys, if I multiplied out this binomial right here, I would get a trinomial with a square root of x middle term. That does not square nicely. So when we ask, is h of x equal to x, question mark, is f of g of x equal to x, question mark? The answer is no, it is not. And what that tells us is that f and g are not inverses. They are not inverses. All right. Moving on to question 11, we're going to do the same calculation. So I want to know, is f of g of x equal to g of f of x equal to x? And so for the first one, f of g of x, here my outside is f, so it's 2 times something minus 2, and my inside is 1/2 x plus 1. And so what we do, f of g of x equals 2 times something minus 2, and that something is 1/2. I didn't leave myself enough room in this parenthesis set, guys. 1/2 x plus 1. And so distribute that 2. And what you get is f of g of x equals 2 times 1/2 is just 1x, and 2 times 1 is 2, so 2 minus 2. And so f of g of x is equal to x. So that's good. That's like the first check mark, but we have to go the other way as well. We have to check g of f of x. So g of f of x equals, and here my outside is 1/2 times something plus 1, and my inside is 2x minus 2. And so g of f of x is 1/2 of something plus 1, and that something is 2x minus 2. Distribute the 1/2. We get 1/2 times 2x is just 1x. 1/2 times -2 is -1, and then plus 1 from the end right there. So g of f of x is just x. And that is the second, we were looking for that. We want them both to be x's. And so since f of g of x is equal to g of f of x is equal to x, f and g are inverses. All right, guys, let's look at this last set. Let's look at this last set. 12 and 13, they want us to determine whether the given functions are 1-to-1. And remember that 1-to-1 means that the function is an inverse. Or, I'm sorry, that f is a function. So f is a function, but also f inverse is a function. So if we're looking at number 12, f of x equals x squared. Oh goodness, y'all. Equals x squared. That is a function. If we graph that, that's a parabola. It passes the vertical line test, right? Just crosses once, anywhere we draw the line. But the inverse of that function, is a sideways parabola. This is the inverse. And if we draw the inverse, we see that it does not pass the vertical line test. So the inverse is not a function. And what that means is that y equals x squared. Oh dear, guys, I think the stylus is getting a little sad. It's a little tired. Y equals x squared is not 1-to-1. All right, looking at number 13. Guys, this is a function. Each x value has one y value. 25 maps to 250, 30 maps to 300, 45 maps to 450, and 70 maps to 700. This is a function. If we went the other way, which is inverse is the other way, right? Inverse would be right to left. And so if we went the other way and drew arrows, would we just have one arrow for each y value? And the answer is yes. 700 would go to 70, 450 to 45, 300 to 30, and 250 to 25. Because they each map only once from right to left, then this is a 1-to-1 relationship. That set of points. If it wasn't a 1-to-1 relationship, you might see something like 25 to 250 and 300 and 30 If you saw 25 to 250 and then also to 300 and 30 to 450 and also 700, the 2 arrows each, that would be not 1 to 1. And again, that has nothing to do with our problem. That's just an example, an illustration of what it would look like if it was not 1 to 1. Okay, but our function is 1 to 1. It is 1 to 1. Yay! All right, guys, that is your review for inverses and composition of functions. Make sure that you bring your review with you when you come to retake the test.